Okay, good day, everyone. Uh, I'm here to present on a title: seismic phases and description. And my co-partner here in this presentation is Tijani Tomitope Rukayat, and I'm by name Meshak Marcus of Department of Physics. My course is Applied Geophysics. I'm presenting on seismology, Physics 752. First of all, I want to take us on a recap of our previous topics that we have taken. We have also looked at some quiet definition. We understand that seismic waves are reflected and they are refracted and converted from P to S wave and from S to P waves. We made to understand that phases are named according to the path through which they follow in the earth, and we understand that each category concerns each seismic wave concerns of several types of seismic phases, which are all propagated through the earth with different velocity, amplitude, and particle motion. And we also learn about the types of waves, which are body waves, which is divided into P and S waves. We also understand about surface waves, which is also divided into love wave and relay wave. So for this topic is about the modified nomenclature of seismic phases that are concise, consistent, and self-explanatory on the basis of agreed rules. So in this topic, we are going to see our introduction. We are also going to learn about some terms and conditions, such as the crustal phases, mantle phases, core phases, acoustic phases, and deep phases. And we are also going to learn about the standard letters, signs, syntax used for describing these seismic phases. We have capital letters. We have some exception in which capital letters are not used. We also have complex standard, which comprises of small letters and capital letters. We also have pure reflected waves, and we are also going to look at the broad teleseismic phase of the seismic waves, in which will involve some diagrams for us to see. So first, in our introduction, we made to understand that for every seismic velocity within the earth, there is a possibility of conversion between the S and the P waves, which I mentioned earlier. And there are two types of individual letters that stand for primary waves and surface waves of the seismic phases. Uppercase letters denote through a part of the earth, e.g. P or S, and lower cases denote reflection from boundaries. And we also learn about reflected waves, which Ali took us on that, made to understand some of their explanation and the rest. We learn about their importance in oil and gas industry. We learn about relay wave, which is used in studying the earth during an earthquake. We see how reflected waves are used in studying shallow depths and the rest. And this reflection can cause by different reasons. Sometimes it's due to discontinuity in the mantle or due to discontinuity of boundaries that it can be reflected. Sometimes when it encounter a different kind of material, such as when it is passing, when it pass through a solid and encounter a liquid, there is a form of reflection that occurs. We are also going to look at phase. We said phase is an alteration current represent of a wave motion. Under that phase, we have acoustic phase, we have hydroacoustic phase, we have tertiary waves, we have mantle phases. It is when a longitudinal or a shear wave propagation from a surface below the upper mantle. It is represented in the International Association of Seismic and Physics of the Earth interior list as P and S. So these standards are being formed by the word IASPEI, stand for International Association of Seismology and Physics of the Earth interior. So The list of these phases was approached by the Commission of Seismological Observation and International and adopted by the International Association of Seismology of the Physics and the Earth Interior on July 2013. So it has been long that this thing is a world standard organization. So wherever you go, these are standard rules that follows. And you can see there is a site over there that you can get the material if you want to, and you will have everything about the publication that are available on the website. Also understand that the whole of this thing is for data analysis and for other users to understand, to ensure that a standardized data reporting and exchange info. The whole idea is also for research and practical application, and to also determine the identification of the types of phases in real seismic record provided in stations. Made to understand that when the seismometer or the seismogram recorded the seismogram recorded, there is an interpretation to it. We made to understand that P waves first arrive before S waves, and so on. But in this context as a whole, we are going to look at it in two forms. That is, in teleseismic, the wave propagation is divided into teleseismic, that is a distance greater than 200 kilometer apart, or a distance greater than 10 degrees from the source of the earthquake, or regional, a regional less than 2000 kilometer apart. That means it is between 1 degree to 10 degrees from the part of the occurrence, that is the event center. So the in our next headline, we have standard letters, signs, and syntax used for describing of seismic phases. We have the capital letters. At the end of this, we'll see some diagrams and we'll see the explanation attached to it. Like individual capital letters that stand for primary seismic waves include, we have P, we have K, we have I, we have S, T, and J. Like J is a transverse wave that travel through the earth's inner core. If you check the bulletins, you will see it. And we have P is a longitudinal wave that travel through the earth crustal and mantle from underneath primi. It's a Latin word that is first wave, and so on. So all these are standard letters. So when you see on that, when we go to diagram, you will understand more of what I'm saying. And we also have some exception that I use, like a capital letter N used in the nomenclature does not stand for a first name, but rather for the number of legs travel, or N-1 reflection made before reaching the station. N should usually follow the first symbol to which it applies. So, and we also have some lower case letter P and S may stand in the case of seismic event below the earth surface for the relative short upgoing legs of P and S waves, which continue after reflection and possible conversion at a free surface are downgoing P and S waves. So we have some exception of this. Example: capital letter P, small letter p, capital letter P, small letter S, capital letter S. All these are exceptions. So when you see this form of things does not stand for either for capital letters or for small letters, they are exceptions, so they can mean a different thing. And mind you that when you see a capital letter, it referring to the body waves, and the surface waves, they most cases use small letters. Many researchers are going up and many research is going on. So multiple reflected P and S wave faces as lowercase letter P and X respectively. So we also have lower cases. Single lower cases letter generally specify that part of the earth crust or upper mantle in which a phase has a turning point, or at which discontinuity it has been reflected or eventually converted. So in a general context, at the upper mantle in which a face has its turning point, or at which discontinuity it has been reflected or eventually converted, single lowercase letter generally specify that part. So e.g., we have G following the first name characterized wave bottoming, having their turning point in case of P or S body waves, or just travel surfaces within the upper granitic head crust. Example, we have PG, we have SG. We will all look at them in a diagram and it will give us a more better understanding. We have B following the first name characterized a body waves bottoming in the lower ballastic head crust. So such as granite and ballastic are examples of rocks. So in most cases in that environment, the major they are basalt and granite. That's the major rocks there. And we have M, upward reflection from the outer side of the Mohorovicic. That is a Mohorovicic discontinuity. This is a boundary of discontinuity that has been observed by a great scientist when recording the motion of an earthquake like 100 kilometers, I think, away from the source. And we have C, we have I, we have Z, and so on. We also have example for creating complex standard first names. We'll see some first carry a capital letter, small letter, and a capital letter, while some they have triple capital letters, some they have 4 capital letters, and so on. For example, let's take a one that have 3. We have PKP. It's a pure reflected longitudinal wave. It has traveled the first part of its path as P through the cross and mantle, the second through which the outer core K, and the third again as P through the mantle and cross. An alternative name for PKP is P, which should be read as P prime. So these are standard. So when you see a capital something like this, that it has passed through the mantle, cross, and through the outer core, that's another standard. We also have a one that carry like 5 alphabet, such as it is also a pure reflected longitudinal wave. It has traveled the first part of its path as P through the cross and mantle, the second through the outer core, the third through the inner core, and the fourth and the fifth parts back again through the outer core and the mantle cross. So it's just like a waveform that has moved up to the last stage and it is passing back again, that is reflected back again. So in this case, such as when there is geophones are implanted, in this case we'll observe that the wave have traveled for a great distance and it is being reflected. That's why we are considering a telesemic phase that can go a greater distance, while we said in regional it can go just only 1 to 10 degrees. That's less than 2000 kilometers. We also have pure reflected waves. In this case, downward only reflection at the free surfaces or from the inner side of the CMB. The first symbol is just repeated, such as PPSS, PPPSS. So these are standard. When you go through it, it will give you a more understanding. We'll go to our diagram. It will give us a better understanding of what we are learning. Okay, such as this, we said telescopic phases. In this plot, the seismic event is at the left and the seismic ray path are shown to the possible stations at several angular distance. So here we look at 30, we have a seismic station, 60 we have a seismic station, 180 we have, that's angular distance degree, we have seismic station. Here we can see the crust, you can see the mantle, we can see the outer core and the inner core. Okay, the event occur at the mantle. We can see our first P is reflect from the mantle, is just directly, there is no any contact directly to the first, that is to the cross. So from here, the first P, we can say it is a primary wave, that is arrive first, while the second ones we can categorically say they are secondary waves, and the third one we can categorically say, because of their arrival time, we can categorically say they are surface waves. Okay, in this case we look at P here. They said a primary compressional waves that follow a simple path from event source to the station. And if we look at PCP, a P waves that goes downward through the mantle, the first P is the one that goes through the mantle, then is reflected from the top of the outer core, that is C, and goes upward through the mantle to the station. While if we look at this P drift, we also look at a P wave that has been bent, that is diffracted around the outer core boundary and arrive at a station in a ray shadow of the outer core. So if we look at here, we will say that there is a form of diffraction, that is a bend. So we made to understand from the beginning, we said that they can be reflected, they can be diffracted, and they can be absorbed. Okay, we look at here, in this case we have SS. We said a shear wave that has traveled through the mantle undergoes one reflection from the other side of the edge surfaces and travel again through the mantle. Second S, unlike the most of the reflected waves, there is a separate letter to denote the reflection at the surface. It implicit. And if we look at here, this is an example like the first one that I read, the PKP. It said a P wave that has traveled through the mantle P, being transmitted across the outer core boundary and travel through the outer core. Okay, look at it. It first travel, then to the outer core, then it's been transmitted across the mantle outer core boundary as K, then transmitted back across the outer core mantle boundary and travel as P waves to the station. So from here it travel at P waves to the station. Travel at P waves to the station. And we made to understand that because of the large difference between the P waves velocity in the mantle and the outer core, these waves is bent, refracted strongly at the boundary. Seismic waves can follow slightly different path, labeled PKAB and PKPC, and still arrive at about the same time. So most times we consider the arrival time, but in this case they can travel on several paths and still arrive at the same time. We also have the PKIKP, this phase that follows a series of paths similar to KIKP phase, except it was reflected off the boundary of the inner outer core boundary, that is the I part of the path, rather than being transmitted through the inner core. So we look at it from here. It is being transmitted, it passed the outer core, but at the inner core there is a kind of outer core outer core boundary, so it get reflected back to the different station. And we said in deep phases, a number of depth phases are referred to in this process, in these proceedings. The part of these phases are nearly the same as P waves. Deep phases also result from a reflection from the earth surface near the epicenter of the event. The time delay between the P wave and the phase is proportional to the depth on. So they have their also standard, such as the P small letter P capital letter PAP wave that's stated outward from the source P, reflected off the earth surface and travel to the station as a P wave. We also have SA, AN, and S wave. that stated out upward from the source S reflected off the Earth surface and also converted to a P wave. Mind you that it was an S wave that stated out from the source, but when it get reflected off the Earth surface, it get converted to a P wave, which then travel to the station at P waves. So we have seen a form of conversion from P waves to S waves. For instance, from here we can look at example of capital letter and small letter. Here is the upper cross, lower cross, and this is the mantle. At the upper cross we have PG, SG, a short event station distance at the upgoing P, that is S waveform, a source in the upper cross depicted here, or a P S waves bottoming in the upper crust at a large distance. The PG first include arrival resulting from multiple P waves vibrating with the entire crust that propagate a group of velocity around 5.8 km per second. So we look at it from here, you just go directly to the source, while from here it passed through the upper crust down to the lower crust to the mantle. From here there is a form of reflection, back to the source, going back through the same processes. We said a highly simplified representation of the earth crust, which is seldom to simple and flat changes of the crustal thickness, velocity can disrupt crustal phases, notably LG. And we also have that the LG here is a wave group observed at larger regional distance caused by superposition of multiple S wave revibration and S wave and P waves to conversion inside the whole crust. The maximum energy travel within a group of velocity around 3.5 km per second. So these are some of the nomenclatures that we have, and if you take your time, you go through the site, you will see more and more explanation to that. And thank you everyone for listening, and I really appreciate your effort and time. God bless you all. But one thing that we should note, that there are different form of nomenclatures. Just like when a chemist see a CH4, he know that it's a methane. Also, there is a provision for every seismic phase with this nomenclature. Thank you very much. God bless you all. Thank you.